Hi everyone, welcome to Random Thoughts with Alex. It's been a long time since I've made a video, so I would like to get back into it. I've always meant to use this channel to make some fun videos about using science and math to calculate things that are kind of interesting and fun to look at. So today I would like to take a look at how do viral videos grow. And when you ask people this question who have thought about it and who know some calculus, they will tell you the answer is by exponential growth. So let's take a closer look if that's really true. I think it's not quite accurate enough. I think we can do better than saying that viral videos or viral tweets or anything in social media that grows virally, that they grow exponentially. So let's take a closer look at that. First of all, why do we think that viral videos grow exponentially? Well, it's fairly straightforward. You start with a small group of people, let's say one person who watches a video, who reads a tweet or whatever it is that we're interested in. And by some mechanism, the next day or the next hour or the next any time interval really, a second person gets to see the same information, watch the same video, and so on, which can be the first person telling another person, or it can be some kind of algorithm that recommends this video to another person based on the fact that one person has seen it. So at that time, two people have seen the video. Next, the process repeats, and the two people who have watched the video are now leading on two other people to watch the video. So now there are four. And the next generation after that, those four viewers lead to four more viewers and so on. So you can see 1, 2, 4, 8, 16 and so on. And that is indeed exponential growth. So it seems like this is a very reasonable assumption to say that viral videos grow exponentially. But is it really? Let's take a look at a plot of a exponential growth as a function of time. So what I'm showing here is the progression over 3 weeks, where the fraction of the number of people who will ever watch a video have watched the video as a function of time. In the beginning, that fraction is very small. We're assuming that at the beginning, only 1 in 10,000 people have watched the video, and we look at how it evolves from there. The first week, we don't see a lot happening. We're assuming that every day, the number of viewers doubles. So after a week, we're still at maybe 1%, still very small fraction. But then in the second week, all of a sudden, we're going from this small fraction to everybody having seen the video. Everybody who will ever see the video has seen the video within the first 2 weeks. Now, this might seem a little odd in itself. The continuous growth is kind of what we're expecting with viral growth, so that's fine. But what this plot indicates is that the growth is faster, faster, and faster, and faster. And all of a sudden, everybody's watched the video, and all of a sudden, nobody watched the video anymore. There's no more further growth. That's not really how viral videos grow, or how viral tweets grow, or how social media have viral events. Typically, it grows faster, faster, and faster, and then it peaks, and then it slows down. The virality is out of it, and we no longer see that kind of behavior. Now we have fewer and fewer people watching this video or retweeting or whatever. So this model doesn't really capture it much. It captures the early stages of a viral video. It does not capture the late stages of a viral video. And to see why that is the case, well, let's first take a look at the math. In order to better understand how we can do better, we need to look at the math. So the change of the number of viewers is a constant value times the current number of viewers. And this is a differential equation. When we integrate that, we get this exponential function, which is why we say that viral videos grow exponentially. However, this does not capture everything. Let's go back to our model earlier where we said, okay, every generation of viewers doubles in comparison with the previous generation of viewers. However, there's a point where there's so many viewers that it's becoming very hard to find new viewers. And so what will happen is something like this. So after a lot of people have seen the video, the algorithm will recommend this video to a person who's already seen the video. Now that person is probably not going to watch the video a second time, so that means that the growth starts slowing down. And that we need to capture in the model if we want to have a realistic description of what's happening in the later stages of a viral video. So that brings us to what is known as the logistic equation. It tells us that the increase of the number of people watching a video is again a constant number multiplied by the current number of viewers times 1 minus the fraction of people who have seen the video. And this 1 minus, this is essentially the probability that a new person who has been introduced to the video has not yet seen the video. And that's what we need to include. So the probability that we have a new viewer multiplied by the probability that that person has not seen the video yet. So when we incorporate that, then the curves look something like this. And this is looking a little more realistic in the sense that, yeah, we still have the virality. It grows faster and faster and faster. But then eventually it peaks. When it's over the peak, the rate of growth of new viewers slows down until everybody's seen it. And then, of course, it doesn't grow anymore at all. Mathematically, we can show that the behavior is like this. This is a not too complicated function that describes this function. This is known as an S-shaped or a sigmoidal shape of a curve. It is symmetrical around the point over here. So the growth here, the acceleration here all the way to 0.5 equals the deceleration after 0.5. And that's what this gives us a pretty realistic view of how a viral video might evolve in later stages. So when we just take a look at the new viewers, we get something like this. The exponential curve, as we've seen, it has this rapid growth of new viewers until everybody's seen the video, and then all of a sudden we go from a lot of new viewers to no new viewers at all, which is not realistic. Whereas the logistic equation, it shows the success increases, it peaks, and then it goes down. After 2 weeks, the success of the video starts slowing down until nobody watches the video anymore because everybody's already seen it. So this equation that I call the logistic equation is also known in population dynamics, for instance, as the Verhulst equation. So it's an equation that is used in ecology, microbiology, and so on to describe how species have a population that grows over time, but when the resources run out, that growth stops. And the same equation that describes virality can also be used to describe the evolution of populations of animals, microbiota, and so on. Another case where we can see this behavior is in trends, say in new technology. For instance, how rapidly does have people switched from a cell phone to a smartphone, for instance. It describes very similar behavior because people who buy, say, an iPhone, they typically first bought one because they heard about it from friends who already had one. So the more people who had an iPhone, the more they spread the word of mouth, the advantages of the iPhone, and so more people start buying it. But we run into the same problem that eventually most people already have an iPhone, so there's not a lot of people anymore to talk about the iPhone because they already heard about it. and then eventually that slows down. We currently are seeing a similar behavior with the transition from gasoline-powered vehicles to electric vehicles, and we can expect that this is going to continue a similar trend. But there's a subtle difference when we're looking at, say, iPhones or electric vehicles, because people don't buy cars all the time, or they don't buy cell phones all the time, whereas people do watch videos all the time, or they watch they're on Twitter all the time, and so on. So there is a subtle difference which I may discuss in a separate video to incorporate the fact that people only buy when they're ready to buy a new car. We can model that also and look at the trends, and that allows us to make predictions on how the electric vehicle market is going to evolve over time. That could be a very interesting video for the future. I hope you liked this video. If you do, please like and subscribe, and I will see you with the next one.